All right, here's part 2 of our video. Oh, whoops. Part 2 of work, energy, and momentum notes. So here's the difference between these two formulas for gravitational potential energy. The formula with which you are familiar, the MGH, that works when you're very near the surface of Earth. Uh-oh. Okay, never mind, false alarm. Okay, so this works only close to Earth, because close to Earth, the force due to gravity right here is the same as the force due to gravity right here. Now, when you're much farther away, so this is Earth right here, the force due to gravity here is much stronger than the force due to gravity out here. So you know that the formula for the force due to gravity, this F equals gm, so that's Earth, that's U, and r squared. This is the distance from the center of Earth. So if you were to go, this is sort of, let's say this is drawn to scale, okay? So this astronaut, are 1 Earth radius away from the surface of Earth. The force due to gravity would actually only be 1/4 the force on the surface of Earth, because the radius has been doubled, so that's r squared. Don't distract me, I'm recording. Thank you. So this potential energy looks like this formula, where it's basically if you take force and you multiply by r, and this is kind of a derivation, and you multiply by r, these cancel, and this gives us work. We can sort of do a calculus type thing, and we can also take this and look at the special case when it's right here, and it should simplify to this. So maybe in a future video we'll do that. But the bottom line is that you use this if you are near the surface of Earth, and if you're far away from the surface of Earth, you're going to use this. And I'd like to bring to your attention the negative sign, because for this situation, 0 is defined as out at infinity. Okay, so you're out at infinity, the force is essentially 0, but when you come in closer and closer and closer, gravity pulls on you and pulls on you and pulls on you. So you have a negative potential energy, meaning it would take work to move you back out to infinity. So I didn't make this up, this is the way it is. When you calculate this, this is the opposite of this is the work required to bring the object out to infinity. Okay, just got interrupted, so I kind of forget where we were, but I think we were talking about where 0 is defined. So in general, 0 is defined as the ground when you're calculating the potential energy. It doesn't have to be that way. For example, you could define 0 to be a tabletop, and then the block would have a negative potential energy down here. It is arbitrary. But more specifically with this IS, and the reason we have a negative is that 0 is defined as infinity. Okay, so let's see, the potential is the work required to move object from that position out to infinity. And then, oh, oops, that was a mistake, that line right there. So this would have some gravitational potential energy, and it's basically a measure of how much work would be required to move it out to infinity. And I know you're thinking, well, wait, it moves at an infinite distance, and work is force times distance, so if it's an infinite distance, wouldn't that be an infinite amount of work? Not necessarily, because the force goes to 0. So this is kind of a calculus thing where the distance is going to infinity, but the force is going to 0, and so you have 0 times infinity, ha ha ha, which can be anything. I love it how that works. Okay, conservation of energy. I hope you're not totally confused and turning this video off right now. Conservation of energy, the total energy of the universe remains constant. And you know, there's also something here, a detail that I didn't write, but I'm going to. and that's E equals mc squared. So Einstein, physics badass that he was, describes the sort of equivalence between energy and mass. So if we were being more specific, we would actually say that the total energy and mass of the universe remain constant. Energy of a closed and isolated system remains constant. This is normally what we're using when we're using conservation of energy to solve questions such as, a roller coaster or an apple falling from a tree or something like that. Closed and isolated, if you know what those terms mean, great. If not, I think it's on the next page. Frequently, we're just talking about mechanical energy, so that is the sum of potential plus kinetic. Sometimes when we're dealing with, oh, here come the middle schoolers, I'm going to put this on pause again. Well, actually, I think we're done. We'll move on to the next page.